I've got grams and nanograms. Okay? 5.67 nanograms. Nanograms is not what I want. Grams is one step. 1 nanogram, 10 to the minus 9 grams. That's my definition. My answer works out just peachy in scientific notation, times 10 to the minus 9 grams. If I want to write it in regular notation, that means I need to move this over 9 places. So I get 0.00000000567 grams, which is also correct. I just think it's easier to write it like this once you get the hang of it. So again, I went over 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places to get the decimal point there. Millimeters and 54 kilometers. I've got 54 kilometers. Automatically, kilometers goes in my denominator to cross cancel. My base unit goes on top. I'm not done. I want to get to millimeters. So that means meters in the denominator, millimeters on top. Dimensional analysis, I've chose the correct units to get to where I need to be. I come here and fill in 10 to the third, 1. 10 to the minus third. Solving simply my units. I got millimeters, great. Coefficients, just 54. So I get 54. My powers then, my exponents here, I get times 10 to the 6th. 10 to the positive third divided by 10 to the negative third goes in 1,000,000 times. And then my unit. This is not the correct units for the answer. To do this, if I'm going from here to here in scientific notation, it becomes 5.4 times 10 to the 7. If I go this direction to fit the decimal point in, I had to add 1. Or, if I'm going to write it out, this says add 6 zeros behind this 4, or I get 54 million millimeters. Yes, no? Maybe so. Starting to look pretty repetitive. Starting to make a little bit of sense. Okay. Yes, ma'am.
So when you have a negative exponent in the denominator, you add it?
Okay. Whatever I have here, if I'm doing this, b to the n divided by b to the m, the rule is this answer becomes b to the n minus m. That's my math rule. So if this is negative 3, if b is 10, so this is 10 to the third divided by 10 to the negative third, my answer is 10 to the 3, subtract. So if I subtract a negative, it's the same as adding a positive. Okay. Centimeters in millimeters. So we got 0.62 millimeters. We're trying to convert to centimeters. Millimeters is not my final answer. Meters is my base unit. Meters is not my final answer. So I put it here to cross cancel. Centimeters is where I want to be. I plug in 1 millimeter, 10 to the minus 3 meters. 1 centimeter, 10 to the minus 2 meters. If I do this, If I'm going from millimeters to centimeters, I expect the number to get smaller because I'm going to a bigger unit. Okay, this is like from going from pennies to dimes. Okay, so when I do this, my answer, 0.62 millimeters, or sorry, 0.62, coefficient hasn't changed yet. I've got 10 to the third, 10 to the minus 2. This is times 10 to the negative 1, and this is centimeters. Useful notation, not the correct answer. All I did was treat my units, treat my powers, treat my coefficients. To get this in correct scientific notation, I'm going to go this way, which means if I'm going that way, I have to subtract 1 here. This becomes 6.2 times 10 to the negative 2 centimeters. Or, if I simply want to write this number as a number, this just means move the decimal point 1 more place to the left, so I could get 0.062 centimeters. Either one of those is the correct answer. Didn't ask for you or tell you that you had to write it in scientific notation. So we have this. Then we had milliliters in 22.4 liters. So we start 22.4 liters times the fact. Well, liters I want to cancel. Milliliters goes on top. One step. I have the fact for 1 milliliter. There are 10 to the negative third liters. My units are correct. I'm at milliliters. Great, that's what I wanted. My coefficient is simply 22.4. I've got 10 to the 0 divided by 10 to the negative third should give me a 10 to the positive 3. So this would be times 10 to the positive 3. Useful notation, not correct notation. So then I have to choose. Am I going to leave it in scientific notation or not? If I'm leaving it in scientific notation, I'm going to move this over and add 1. So this becomes 2.24 times 10 to the 4 milliliters. If I'm going to simply write it as a number, this says move this over 3 places. So I get 22400, or 22,400 milliliters. Either one of those is a correct answer. Okay, for a party, you bought a 2-liter bottle of cola. Part A says convert milliliters. So I have 2 liters times the fact. I want milliliters as my answer. Liters goes in the denominator, cross cancel. This is 10 to the minus 3. This is 1. I get 2,000 milliliters, or 2 times 10 to the third milliliters. That would be part A for 6. How many glasses can you fill? Here's where I have to come up with my own equivalents. 1 glass equals 200 milliliters. I was given that in the problem. There's my equivalents. I get 2 conversion factors. It's either 200 milliliters per 1 glass, or 1 glass per 200 milliliters. I plug in 2,000 milliliters times the fact. Well, I want glasses as my answer. Milliliters is going to cancel. I want to use this conversion factor. So it is 1 glass per 200 milliliters. I get an answer that is 10 glass. So, this was not explicitly given to you, but it was given to you. When they said that a glass holds 200 milliliters, they're telling you, there's your equivalence.